The moon is rusting, and chances are it's happening because of Earth. You'd say that since they're more than 370,000 kilometers apart, 384,400 kilometers, they can hardly directly influence each other in such a way, but they do actually have a special connection. The moon affects our home planet as well, and you can see it while observing ocean tides. As Earth rotates, the moon's gravitational force pulls the water on the nearest side of Earth. It creates a bulge. At the same time, another bulge forms on the opposite side because our planet rotates, and it causes a centrifugal force. And then, the planet continues to rotate underneath these bulges, which is why we have 2 low and 2 high tides every day. Plus, the moon wobbles every now and then, every 18.6 years, tilts more or less, and causes changes in ocean tides. 1-3 sekpause. And in return, Earth's atmosphere is making our satellite rusty. Rust is that reddish substance you see on old gates or nails. Oh, and you know Vermilion Cliffs and the Grand Canyon. They also have that specific red color thanks to rusty iron in the rocks. It forms when iron reacts with oxygen and water. Rust is common even on Mars. The planet's trademark color comes from the rust that's been there for a very long time. That's how the red planet got its nickname in the first place. Normally, you wouldn't say the moon is a place that would rust that easily since it's dry and doesn't really have an atmosphere. But a spacecraft, JPL Moon Mineralogy Mapper, studied the moon back in 2008 and detected spectra, wavelengths of light, that were reflecting off different surfaces of the moon. That's why it could analyze the lunar surface better. The data it brought showed that the lunar poles had different compositions than the rest of the moon. They had rocks that contained a lot of hematite. That's a specific type of iron oxide, or simply rust. Oh, 2-3 sekpause. No one expected that because there shouldn't be so much rust on the moon, considering the conditions there. But we know that there's some water up there on the surface of our satellite. That's why a few new theories popped out about different minerals the moon could be hiding. It's possible that they formed because water had reacted with the rocks. For iron to get this rusty hue, it needs something we call an oxidizer. That's a molecule that removes electrons from materials like iron, such as oxygen. But the solar wind keeps hitting the moon all the time, and it brings hydrogen with it. And hydrogen has the opposite effect. It gives electrons to other molecules. Earth has its shield from the solar wind. It's our magnetic field. But the moon doesn't have such protection, and because of that, rust shouldn't be able to form on its surface. But this process still happens, and it could be Earth's fault. Start 3 sekpause. The moon itself doesn't have an atmosphere that could provide enough oxygen for iron to rust, but apparently, our planet is generous enough to donate some of its own atmosphere. The oxygen from our atmosphere travels all the way to the moon, following something called magnetotail. That's a long extension of Earth's magnetic field, which can reach the near side of the moon. That's exactly where most of the hematite was found. And during a full moon, the magnetotail blocks 99% of the solar wind, which would normally influence the moon more. It's like there's a temporary curtain over its surface, which gives enough time for rust to form. But there's still one important thing necessary for the appearance of rust: water. It's not like you can find water that easily if you decide to take a walk across the moon. Most of it is frozen and hidden in areas that always remain in cold shadows. Those spots are far away from where most of the hematite was discovered, so it's hard to tell how the water got there. But for 3 sekpause. But there's an interesting idea. All those dust particles that hit the moon might be freeing free molecules of water that are locked in the surface layer of the satellite. This is how water ends up mixed with iron. We don't know exactly what these dust particles consist of. They might be carrying some water too. As they hit the lunar surface, this might create heat, which boosts the oxidation process, and more rust forms. So, our planet does certain things that change the moon, but humans do the same. A probe that landed on the lunar surface back in 1959 was the first human-made object that touched the moon. That's also when we started altering the moon in unpredictable ways. Scientists call this the Lunar Anthropocene. I have a 3-sec pause. It's like an analogy with Earth's Anthropocene, a period when human activity made a big impact on the planet. It's not like we can choose a certain starting point when such an activity began, but we now know that things we have done over the history of our existence have really changed the environment of our home planet. We don't have any people living on the moon yet, but we've already left some traces there. After humans first came to the moon, we've had many missions there. We left some landers and flags, moved lunar soil, brought golf balls, scientific equipment, and even some human waste. Plans for the future? Send more missions up there, and even potentially create an infrastructure where some of us could live, study the moon's resources, and send them back to Earth. That's why it's important to talk about the lunar Anthropocene, to remind ourselves we have to be responsible and take care of our heritage. M6 3-sec pause. Many people are confused about why we sometimes see the moon during the day. Some even believe it's something new that didn't happen before, especially after they started sharing a low-res picture of what looks like a full moon in the middle of the day. Some have pretty unusual ideas that the sun isn't the same color as it was before, either. Allegedly, it used to be more yellow. The sun hasn't changed its color. It's still blue-green, but it's possible that we saw it as more yellow when we were younger, because before, pollution wasn't as bad. And when it comes to the moon, we can see it both at night and during the day. It's brighter at night because there's no light coming from the sun. But it's not like it goes anywhere during the day. It's still there, but we just don't see it during the new moon phase. That lasts a couple of days, and during that period, the moon comes pretty close to the sun. The scattered light coming from the sun makes our satellite less visible to us. Pause. Speaking of the moon phases, they're easy to recognize when you know what to pay attention to. First, there's the black moon, which can mean a couple of things. One definition says that it occurs when we have 2 new moons in a month. Another one claims that the black moon happens when there's no new moon in a month, and that only happens in February. A blue moon is not called that because of the color. It's the 3rd full moon in a season that has 4 full moons. And a supermoon occurs when a full moon coincides with the moon's closest approach to Earth in its elliptical orbit. That's why it looks bigger than usual. 8-3-sec pause. Sometimes you can look up to the night sky and see an eerily red sphere up there. It's not about signs that tell us that the end of the world is coming or that werewolves are roaming around. But yup, blood moon is a good inspiration for stories like that. In reality, it's just an astronomical event when our planet casts a reddish shadow on the moon, and that happens when Earth comes between the moon and the sun, which is called a total lunar eclipse. Earth's little companion catches some red light coming from our atmosphere. That is why you see that specific color. When you see it in the sky, it looks round, but the moon is more of an oval shape, similar to a lemon. This shape, flattened with a bulge on each side, came out billions of years ago, when extremely hot tidal forces shaped its crust. They heated up some regions more than others. Gravity from our planet has helped to exaggerate this lemon shape over time. When they were getting ready to send missions to the moon, some researchers were worried because there was a thick layer of dust on the lunar surface. They were afraid seas of dust were both soft and thick enough to swallow their lunar lander. But even though the surface there is dusty, this layer is just too thin to cause complications. Our moon certainly isn't the biggest one in the solar system. The champion here is Ganymede, one of the 79 moons circling around Jupiter. But our moon is the largest in relation to its parent planet. It has a diameter of more than 2,000 miles, which is slightly bigger than 1/4, the size of the Earth. Pluto, for instance, has a smaller moon-to-planet ratio. Its biggest moon, Charon, is almost the size of Pluto, which is why it looks like it's a double dwarf planet system. How long would a walk around the moon take you? When the Apollo astronauts were there, they managed a walking speed of approximately 1.3 Mach/s. On average, you walk twice as fast down on Earth. The low gravitational force on the moon would give you significantly less traction on the ground. But those special spacesuits astronauts were wearing were never actually designed for long-distance hikes. In theory, you could maybe reach the speed of 3 moonquakes before you'd need to break into a run. At this pace, you'd travel 6,770 miles, which means making a circle around the moon in 91 days if you were walking non-stop. Why does the moon change its shape? It goes through different phases each month, starting from the new moon and gradually going to the full moon, just to do the same thing all over again, but in reverse. The sunlight hits one half of the moon at a time. This gives it a night and a day side, just like we have it here on Earth. The shape we see the moon in depends on where it's located compared to the sun. If it's directly between us and the sunlight only hits the side we don't see. That's a new moon. It appears completely dark in that phase. But when it comes to the far side of our planet from the sun, its day side completely faces the Earth. That's when we see a full moon. After the initial phase, when the moon is new, we'll see more of its surface in the sky as it orbits our planet. It's something we call waxing. The moon in this phase first becomes a crescent. The first quarter moon is when it's half full. After that, it goes into a gibbous moon phase, when it's larger than half full, but not yet full. After it reaches the full moon phase, it slowly shrinks and goes through the same phases, but in the opposite direction. While up on the moon, you'd probably see human footprints there. True, no one has stepped there since the last Apollo mission in 1972, and the footsteps may stay there for many years because there are no geological activities on the moon, like earthquakes or volcanoes. There are no winds, rain, or other things that could erase these footprints. How would you get to the moon? Rockets are probably the first thing that comes to your mind, but a lunar elevator could be an even better solution, because traveling in a rocket would be a difficult, expensive, and pretty dangerous way to try to reach the lunar surface. Why would people want to go there? It's not just about craters, an amazing view of our home planet, or other unique things the moon offers. It's also full of resources like a rare form of helium, helium-3. Humans could use it in fusion power stations on Earth. We could extract some other rare elements, e.g. neodymium-2, and use them for smartphones and other gadgets. For a lunar elevator, we'd need to stretch a cable anchored to the moon's surface for 250,000 miles toward the Earth. We wouldn't be able to attach it directly to our planet because both Earth and the moon are moving, but we could terminate high in our planet's orbit. We'd have solar-powered robotic shuttles that would move up and down the cable. This is like having a conveyor belt to ferry rare and precious resources our way. The cable would be as thick as a pencil and would weigh 40 tons. It sounds expensive, but a lunar elevator would most likely pay for itself within only 53 trips. The moon is in constant motion. It rotates on its axis and circles around the Earth. And it takes the same amount of time for the moon to make a circle around the Earth and rotate once on its axis, compared to our planet, which rotates on its axis every 24 hours and makes a full circle around the sun in 365 days. So, the moon is tidally locked to our planet, which is why we always see the same side of the moon. One theory says the moon probably formed when a large Mars-sized object, Theia, from our solar system hit the Earth. They collided 4.5 billion years ago when the solar system was still in its early stage, which was pretty chaotic. If this theory is correct, around 60% of the moon is made of lighter elements that are also present in the outer layer of our planet. A lucky set of circumstances lets us see total solar eclipses from our planet. The moon is the perfect size and distance from the Earth to appear the same size as the sun when we're looking at it in the sky. When the moon passes between the sun and us, it covers the sun perfectly. Plus, you can see an impressive halo that illuminates its edges. If it were any farther from us or smaller, a solar eclipse would only look like there's a blot on the sun. Our moon contains the water that kinda jumps around. There's water there locked up in ice. Some water molecules move around the surface as the moon cools and warms during the day. The water gets stuck on its surface until the lunar midday, when the sun is above the upper branch of any of the moon's meridians. At this point, some of the water melts, heats up, and ends up in the delicate lunar atmosphere. Its atmosphere generally contains some unusual gases, including potassium and sodium. Venus, Mars, and Earth don't have these in their atmospheres. So the water stays and floats there until it gets to a cooler area. Then it settles back to the surface. There's a specific anomaly under the surface of the South Pole on the Moon, a giant and an extremely dense blob of metal lodged in the mantle, and most likely, it's altering the Moon's gravitational field. No one knows how such a huge blob of metal ended up trapped under the lunar surface. It could perhaps be remnants of the iron-nickel asteroid. 4 billion years ago, this asteroid crashed into the far side of the lunar surface and created this enormous South Pole Aitken crater. Our natural satellite is shrinking. Its interior is cooling, which results in the Moon getting over 150 feet skinnier, just as a grape wrinkles as it's shrinking down. But a grape has flexible skin, and the lunar surface crust is brittle. That's why it breaks as the Moon is getting smaller. That way it forms thrust faults. One section of crust pushes over the closest part. This has been going on for the past few 100 million years. These lunar faults are still active. They probably produce moonquakes, as the Moon gradually shrinks and cools all the time. Some of these quakes are strong, maybe 5 on the Richter scale. During their orbit around the Moon, astronauts took images of Ina, a quite unusual volcanic deposit. Ina is not that old. It might have formed somewhere between 3.5 and 1 billion years ago. The volcanoes on the Moon were probably active during the age of dinosaurs. If only they could have invented telescopes, they'd probably have a magnificent view of lava oozing from the lunar surface from time to time. The Moon has its own time zone called Lunar Standard Time. It doesn't correspond with the time on our planet. A year on the Moon lasts 12 days. Each day is about as long as a month on Earth. These days got their names after astronauts who walked on the Moon. The days are divided into 30 cycles. The cycles are divided into hours, minutes, and seconds. The calendar started when Neil Armstrong set his foot on the Moon on July 21st, 1969, 2:56:15, Universal Time. It's dark outside, almost 2 a.m. You go outside and look at the sky, and here it is, bright full moon. You might think you know a lot about Earth's natural satellite, but let me ask you this: how did it form? The answer is nobody knows. But, of course, there are theories. The most popular one, called the giant impact theory, claims that the Moon formed during a collision between Earth and another planet. This planet must have been smaller than ours, the size of Mars, and the collision itself probably happened around 4.5 billion years ago. Another theory, called the capture theory, claims that the Moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. But here is one catch. Our planet and the Moon have remarkable isotopic and chemical similarities. So, they must have a linked history, which means the Moon couldn't have been created elsewhere. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet. That's how the Moon appeared in the sky. But again, there's one problem. In this case, the proportion and type of minerals on the Moon would have to be the same as on Earth. But there are slight differences. The Moon is richer in materials that form very fast at high temperatures. There's one more theory, and it's probably the least exciting. It claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. Duh. But these days, a more urgent question keeps astronomers busy. Is the Moon really Earth's satellite, or are these two twin planets? The Moon is big compared to our planet, about 1/4 of Earth's size. That's why some experts refer to our planetary system as a double planet. But how correct is that? If we want to figure it out, we need to give the definition to the word planet. According to the International Astronomical Union, a planet is a space body that orbits the Sun, is massive enough to have a nearly round shape thanks to its gravity, and has cleared the region around its orbit. Now what about a satellite? It's an object in space that orbits around a larger celestial body. If we take the system, Earth the Moon, its center of gravity, called a barycenter, is inside Earth. That's why at the moment, we can't say that we live in a twin planet system. According to this definition, the Moon is the satellite of our planet. Now, let's get back to the past, like 3 or 4 billion years ago. Even though the Moon wasn't a planet, it most likely had a full-fledged atmosphere. It formed at times when powerful volcanic eruptions were rocking our satellite. Gases spread all over the Moon's surface, and it happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurtling high into the air, falling to the ground, and creating lava flows. That's how the basalt basins appeared on the surface of the Moon. At one point, scientists got their hands on samples brought from the Moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the Moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggests the Moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days, our satellite is around 240,000 miles away. That's why the Moon looked much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. These days, the atmosphere of the Moon is almost non-existent, and that's why the satellite can't protect itself from meteorites. The surface of the Moon is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the Moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. And since the Moon is less seismically active than Earth, these craters and other ancient formations stay in perfect condition for centuries. When you look at the Moon, it's the brightest object in the night sky. But in reality, its surface is dark because the reflectance of our natural satellite is just a bit higher than that of asphalt. You might know that the Moon's gravitational pull causes tides on our planet, making the oceans bulge out on both the side closest to the Moon and the one farthest from the satellite. But that's not all. The Moon also slows down Earth's rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The Moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. If one day the Moon floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the Moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Even though the Moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. One theory suggests that they may be happening because the Moon is shrinking as its insides are cooling. Scientists say the Moon has become around 150 feet skinnier than it used to be several hundred million years ago. To help you understand it, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the Moon. It's shrinking and it's wrinkling. But unlike a grape, the Moon doesn't have flexible skin. Its surface is hard and brittle. So, as the Moon gets smaller, the crust cracks and breaks, and its sections get pushed over neighboring parts. Want to know another cool thing about the Moon? A recent study claims that it has a tail, and every month, it wraps around our planet like a scarf. This slender tail is made up of millions of atoms of sodium. and our planet regularly travels directly through it. Meteor strikes plus these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. And the spiciest fact for you, 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it was no larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet. Called 2020 CD3, it was our temporary mini-moon. It didn't stay with Earth for long, though. The asteroid followed a random orbit and slowly drifted away. Temporarily captured objects, such as 2020 CD3, are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction. An asteroid broke off the moon, and now it's super close to Earth. Does it pose a danger to us? Kamo'oalewa, also known as 2016 HO3, spins super quickly as it orbits near our planet. Let's call it HO3 for short. Astronomers found it on April 27, 2016. Compared to other asteroids, it's tiny. On Earth, though, it would be the size of a small building, or about half the size of the London Eye Ferris wheel. They discovered it in Hawaii, and its name roughly translates to a fragment of something that seems to wobble. After some study, they realized that this asteroid might be a chunk of the moon that got blasted into space. There's a part of the moon called Giordano Bruno crater, named after an Italian philosopher, that guy who had to pay quite the price for his ideas. If you look at it from space, Giordano Bruno stands out because it's surrounded by some rays of material. They're super huge, stretching over 150 kilometers, and are still bright. This means that an enormous boom once happened there. There's an interesting story about this. In 1178, 5 monks were traveling in Canterbury, England. Suddenly, they saw something strange happening on the moon. They said it looked like the moon was splitting, with flames and sparks. Then there was a darkening that spread all across the lunar surface. In the 20th century, scientists found these records and thought that these monks saw the formation of the Giordano Bruno crater. But later, it turned out that the crater's about 4 million years old. And thank the stars, because such a massive impact, if it really happened in the 12th century, would have gone crazy on our planet. It would have caused a huge meteor storm on Earth. In any case, our HO3 is most likely a piece of the moon that broke off during that impact 4 million years ago. Luckily, there's no need to panic about it. When astronomers spotted this sudden moon piece, they quickly tracked its orbit. Turns out, it won't collide with us anytime soon. It's going to be our quasi-satellite for at least 300 more years, meaning it will follow a path around the sun that keeps it close to Earth without colliding. Its orbit is wild, though. It seems to be constantly looping around our planet in some pretty unique loops, moving closer and going away up and down. And then somewhere in the 24th century, it will go even more crazy, switching to a horseshoe orbit, slowly going away from us. Could HO3 collide with us someday? Maybe. But that could happen over millions of years, when it could leave its current orbit and collide with Earth, Venus, or even the Sun itself. Or maybe entirely ejected from the solar system. Even though it's one of the closest asteroids ever discovered, it's also one of the smallest and most stable ones. This discovery also opens up some exciting ideas about life in the universe. We see that rocks can travel between celestial bodies. There's a theory that life could have been spread all across the universe by traveling on these rocks, like on some space Ubers. Or at least the building blocks of life, like carbon. Maybe life even hitchhiked to our planet on rocks from Mars. HO3 probably doesn't carry any life, but the fact that it can travel for millions of years, carrying stuff on it and feeling fine, supports this theory. Astronomers want to send something to investigate HO3. Back in 2017, a group of students gave an idea of using a spacecraft for it. The China National Space Administration wants to send a robotic probe to HO3 somewhere in 2025. The robot should fly there, collect samples, and bring them back to Earth for study. Unfortunately, you can't see this asteroid in the sky with the naked eye. Its size is about 100 meters in diameter, so it would be too tiny and dim to see without a super powerful telescope. But there is an asteroid that you'll be able to see, and it will be insane. In 2029, a large asteroid will pass so close to Earth that it will be visible to the naked eye. Make sure not to miss it, because this is a once-in-a-thousand-year event. The asteroid is known as 2004 MN4, or Apophis for short. It's much bigger than HO3, about 369 meters wide. This will be the closest asteroid passage ever. This one actually caused some panic back in December 2004, all because there was a 2.7% chance that it could hit Earth in 2029. People were horrified. Even the name, Apophis, is inspired by an evil serpent from ancient Egyptian mythology, a huge monster that fought Ra and always tried to swallow the sun and destroy the planet. Luckily, when scientists got more data, they realized that it would pass pretty close to us in 2029, and we'd be able to see it in the sky. But then it will just fly away like a chill asteroid. There was another worry, though, that during its close pass, Apophis might travel through something called a gravitational keyhole. Basically, that it could travel through a specific narrow region of space, which would accidentally alter its orbit, and then it would make an epic comeback in 2036, like the planet from the movie Melancholia. However, after some calculations, scientists ruled out this possibility as well. Apophis will still come quite close to us in 2036, but it will be about as far away as Venus is when it overtakes Earth, and then Apophis and Earth will just go their own separate ways. On average, an asteroid the size of Apophis is only expected to hit Earth once every 80,000 years. If it did hit us, it would completely destroy a huge area, causing earthquakes and tsunamis all around the world. But it wouldn't cause an apocalypse or anything like that. You'd only be able to see Apophis from Europe, Africa, and Western Asia. So if you want to see it, you might need to travel. The asteroid will look like a fast-moving star in the night sky, shining bright enough to be seen without any special equipment. It would be easy to spot at night, though city lights might make it harder to see. Now, can you imagine that these are not the only guys hanging nearby? Both HO3 and Apophis are a part of the so-called Apollo orbit asteroids. These are the asteroids with orbits going around Earth. An entire group of dangerous fellas. Since they cross Earth's orbit, they have the potential to come close to or even collide with our planet. The first asteroid of this group to be discovered was 1862 Apollo, named after the Greek deity of the sun. It was first discovered in 1932, and the group was named after it. This one was even bigger, almost 1.6 kilometers in size. In fact, it's so huge that it even has its own tiny moon. Apollo crosses the orbits of not just Earth, but also Venus and Mars. Fun fact, even though it was the first one of its kind, telescopes accidentally lost it out of view for over 40 years. So scientists went, oh well, let's just keep the count of things we can see. When Apollo was rediscovered in 1973, it wasn't the first asteroid on the list and got a big number in its name. Apollo will fly near us during the next hundreds of years. In 2075, it will be somewhere around Venus, but it should fly by as well. In any case, there's no need to worry because astronomers are keeping a close track on these guys. If we were in any immediate danger, we'd have known. In order for an asteroid to totally destroy life on our planet, it should be bigger than 9.7 kilometers in diameter, like the one that helped to wipe out the dinosaurs 66 million years ago. but these guys are so crazy rare, we'd probably live on other planets by the time they arrive on Earth. Now don't get all upset, but the moon is shrinking and getting wrinkled, pretty much like a grape turning into a raisin. That happens because our natural satellite has been retaining its inner heat for over 4 billion years, but its core is gradually cooling down and becoming more dense, like me. Unlike a grape's flexible skin, the moon's surface is pretty brittle. This brittleness causes faults to form where different sections of the crust push up against each other, leading to what scientists call moonquakes. So far, our satellite has shrunk by around 45 meters in circumference. It is such a tiny change that it won't affect the look of eclipses or the phases of the moon. Even tidal cycles won't be affected since the moon's mass hasn't really changed. This shrinking process won't directly affect us down here, but that doesn't mean that all humans are safe. Moonquakes caused by the shrinking process have been a concern for years. During the famous Apollo missions, NASA astronauts left seismometers at different points on the moon. Those are devices capable of identifying seismic activity on the lunar surface with exceptional precision. The equipment was operational for several years, and it managed to capture over 12,000 moonquakes ranging in magnitudes from 2 to 5. Up until 1977, the team was able to identify 4 distinct types of quakes. Some tremors, like those caused by meteorite impacts, were relatively easy to identify. But the cause of the so-called shallow moonquakes remains a mystery to scientists, and that can be an obstacle to future missions on lunar soil. As the name suggests, shallow moonquakes occur relatively close to the surface, typically between 50 to 220 kilometers beneath the crust. Recent research suggests that these tremors are triggered by the compression of the moon's surface, leading to the formation of thrust faults, where one surface layer is pushed up and over another. This study also discovered where the epicenters of the strongest ones were. It all started in the South Pole region, precisely where we want to settle down. Interest in the lunar South Pole peaked in 2023 when India's Chandrayaan-3 Chandrayaan mission successfully landed and deployed a rover to explore the area. NASA also has plans for the same spot, and their ambitious goal is to take astronauts there for the very first time. The Artemis 3 mission, scheduled for 2026, currently has 13 potential landing spots at the South Pole, represented by the blue squares here. One of the options is situated within a geological feature called de Gerlache Rim 2, which is a strategic area for exploration. It might have ice because parts of it are completely in the dark, but it's close enough to areas that do have sunlight, which is crucial as a source of power. Now, take a look at the pink dots on that same map. They represent possible epicenters of the strongest moonquakes recorded by the Apollo mission. That means that thrust faults in the area could be relatively young and potentially active, representing a real danger for the Artemis 3 crew. These astronauts will journey to lunar orbit over the course of 30 days, and 2 crew members will descend to the surface, spending about a week at the South Pole. Their moonwalks will be particularly challenging given the extreme temperatures of these permanently shadowed regions. The presence of moonquakes and possible landslides only adds more danger to this mission, as this phenomenon is far more frightening than earthquakes. The strongest moonquake ever recorded had a magnitude of 5.7. You might think that's not a big deal, considering that countries like Chile, Colombia, and Papua New Guinea experienced earthquakes of similar magnitude in 2023 without significant damage. But the gravitational pull on the moon is relatively weaker than on Earth, so what feels like a gentle tremor on our planet might be a real ground-shaking event up there. This happens because you're not as firmly connected to the surface of the moon as you are on Earth, meaning that seismic waves can cause the surface to move more freely. There is also a huge difference in duration. Earthquakes typically last between 10 and 30 seconds, with some lasting up to 2 minutes. A moonquake can persist much longer than that. Our satellite is essentially a solid rigid, and dry sphere. So when a tremor shakes the moon's surface, it resonates powerfully without any natural means of dissipation. Moonquakes can last for a good 10 minutes or even longer, with little tremors sticking around for hours afterward. These new findings about shallow moonquakes won't actually change the potential landing sites for Artemis 3, and they won't affect the duration of the mission either. That's because accurately estimating how often a specific region experiences these tremors is tricky and unpredictable. What scientists do know is that these shallow quakes aren't very common and pose a low risk to short-term missions on the lunar surface. But that situation changes completely if we consider long-term habitation on the moon, and that could happen sooner than we expect. The Artemis 3 mission represents an important first step towards space colonization. China is also making the first moves to establish a permanent lunar base at the South Pole by 2040. Their strategy involves utilizing 3D printing and brick production from lunar soil for constructing the moon base. That definitely sounds fascinating, but putting together a setup like that comes with a bunch of challenges, including dealing with intense cosmic radiation, the lack of water, and of course, long-lasting moonquakes. Over billions of years, the surface of the moon has been hit by asteroids and comets, causing bits and pieces to constantly break off from the impacts. Because of this, all the surface material is pretty loosely packed. So when there are quakes, slopes in the same area can become susceptible to landslides or new faults opening up. Future settlements located too close to these unstable slopes could put everyone living inside these lunar bases at risk. Moondust adds another layer of complexity because without erosion or water to smooth it out, it can harden to the point of being as tough as glass. If we really want to understand how dangerous moonquakes might be for people living and working on the moon in the future, space agencies still need to map out and get new seismic data, and not just from the South Pole, but from the entire satellite. In 2025, the Farside Seismic Suite mission, or FSS, plans to deploy two of the most high-precision seismometers ever built to the Schrödinger crater, which is located on the dark side of the moon. Finding out what's happening on the ground there is crucial for understanding the complex lunar structure and its internal dynamics. I mean, scientists are still trying to figure out whether the lack of recorded seismic activity on the far side of the moon is due to current instruments not being capable of detecting it, or if it's due to some kind of interference from melted material in the mantle. Once they have this answer, it will be easier to fully understand the phenomenon of shallow moonquakes and assess their implications for future neighborhoods on our natural satellite. You might have heard that Earth is also shrinking, but it is a different process. Basically, the moon is getting smaller, mainly because its core is cooling down naturally. The Earth's core is cooling too, but our planet's got this crust with tectonic plates, unlike the moon, which only has one plate. So the energy from Earth's core shifts those plates around, or comes out through volcanic eruptions. Earth is actually losing mass overall due to atmospheric loss. Our planet loses about 45 million kilograms of mass per year, mostly from a leaky atmosphere. Earth's gravity isn't strong enough to retain the lightest particles, like hydrogen and helium, which escape into space. But don't worry, these numbers aren't cause for alarm, considering that our planet's atmosphere weighs about 5 quadrillion tons, a number that I can't even imagine. In other words, it would take many times the current age of the universe for it to completely evaporate. Well, that makes me breathe easier. How about you?